Okay, right now we're going to deal with translations of a quadratic function. And this particular graph that we're looking at right here is y equals x squared. Sometimes we'll see that in function form. It'll say f of x equals x squared, or g of x equals x squared. And the graph here is pretty accurate. I mean, it's a little bit of human error when I try to draw it. It's a little bit wavy, but you kind of get the picture of it. And what we're going to be dealing with right now are the translations, how this particular graph is going to shift up or down, left or right. So let's look at, first we want to look at what our vertex form of an equation looks like. And here is our equation for the vertex form. And I'm just going to move that over to this side here. With this one, what we're concerned about is, what we're going to be focusing on is our A, our magnitude. How this is going to change the graph. My A in this case over here is a 1. There's a 1 written there. We don't, actually it's not written there, it's just implied that there's a 1 there. So that's what we're going to work on here. If A were something other than 1. And so we're going to go through this right now. If we're dealing with positive numbers, in other words, this one right here is a positive number. Alright, so let's write one. Y equals 2x squared. Okay, and we'll plug in a couple points here. We'll try to do this one in blue, just so we can kind of illustrate. Okay, so if x were to equal 1, we can plug in a 1 here. 1 squared is 1 times 2 is 2. So 1, 2 would be our first point. 0, 0 would still be our vertex on this particular one. Okay, if we plugged in negative 1, negative 1 squared is positive 1 times 2 is 2. Now if we do 2, 2 squared would give me 4 times 2 would give me 8. Okay, so we'll go 2, 8 would be right about here. Okay, now we're going to draw a line and try to connect all of those. And what we'll notice on this one is that this particular graph, the one in blue, is a little more narrow than the one that we have in black. And what we'll find out then is for positive, when A is a positive number, let's write that over here maybe. If A is positive greater than 1, the graph ends up being narrower. The graph is more narrow. Okay, so let's look at one to see if that holds true, if it's less than 1. So we'll go y equals 1/2 x squared. We're doing this one in blue, or excuse me, in red. Okay, so if x were to equal 0 squared is 0 times 1/2 is still 0, so our vertex doesn't change. Alright, so let's plug in 1. If x equals 1, 1 squared is 1. 1 squared is 1 times 1/2 would be 1/2. So we go 1, 1/2. It's down just a little bit here. And if we plug in a negative 1, negative 1 squared is positive 1 times 1/2 would be 1/2. Okay, now let's plug in 2 here. 2 squared is 4 times 1/2 would be 2. So we'll go 2, 2. Negative 2 squared is 4 times, is a positive 4 times 1/2 is 2. Okay, and if we go 3, 3 squared would be 9 times 1/2 would be 4.5. So we're going to go 3, 1, 2, 3, 4.5 would be somewhere around there. Same thing on this side. These will be mirror images. So what we're going to notice here with this graph is that it ends up being a little bit wider. Okay, so I'm going to have an arrow on that one. So if A is positive and less than 1, the graph ends up being wider. Okay, and we can see that with our red one there. And the same thing holds true just for the inverse on the bottom portion, okay? If it's a negative, in other words. So if we y equals negative x squared. Well, the graph on that particular one would look almost identical to this black one that we have up top here, only it would be reflected over the x-axis. So we'd still have our vertex right here. It would be, if we plugged in positive 1 squared, would be a negative 1, negative 1, 2, 4 right there, 2, 4 right here, 3, 9, 4, 5, 6, 7, 8, 9 right down here, 3, 9. So the graph would look something like this. It's not a perfect graph, but it's pretty close. Okay. So it's the same thing, only it's negative, so now it's kind of our frowny face. Remember that if A is positive, it's a smiley face. And if A is negative, it's a frowny face. I always remember that. By positive people smile, and negative people frown a lot. But if we were to take the same thing, and let's try one here, and we'll do this one in blue, y equals negative 2x squared. Alright, so let's plug in some numbers here. If x equaled 1, so 1 squared is 1 times negative 2 is negative 2. So 1, negative 2, it's going to be right there. And if x were to equal a negative 1, negative 1 squared is positive 1 times negative 2 is a negative 2. Okay, and then if we decided to go to 2, 2 squared would be 4 times negative 2 would be negative 8. So it would be right here. And if we wanted to graph that one, we could. Notice how it's just on the inside here. Keeps going down. I messed up just a little on the vertex. The vertex will come actually all the way in here. Okay, and it'll touch that 0, 0. So it is the same direction. It's still a frowny face. But this time it's a little more narrow. So if A is negative, if A is a negative number, and it's less than negative 1, then the graph is more narrow. Narrower. Okay, now let's try it with a one that's greater than negative 1, but still a negative. So we'll go y equals negative 1/2 x squared. Okay, so we'll do that one in red. 0, 0 still works for that one. That's still our vertex. And in fact, that's been our vertex on all of these. But if A in this case were negative 1/2, so if x were to equal 1, 1 squared is 1 times negative 1/2 is negative 1/2. So we've got 1, negative 1/2, somewhere right around there. Negative 1, negative 1/2. 2 squared would be 4 times negative 1/2 would be negative 2. So 2, negative 2. 3 would be negative 4/2. That'll put us right about here. So if we notice on that particular one, missed that dot there at the end, but that one ends up being wider. So our rule is if A is negative and greater than negative 1, the graph is wider. It's a long video with a lot of information, but that's kind of what we're looking at here. And this, I know that we did these numbers with just whole numbers in front. We just did x squared just for illustration purposes, but the same rules are all true for this A right here. No matter what else is occurring over here, that A will tell you if it's wider or narrower than the original graph of y equals x squared, this big black one right here.